The star blinked once, then again. Not with rhythm, not with reason, but with the kind of chaotic precision that shouldn't exist in nature. Over 97 days, its light dimmed 28 times, without pattern, without warning, as if something enormous was passing in front of it. Not a planet, not a cluster, and definitely not a star spot. Whatever it was, it moved with intent. This case is about a single star, HD 139139, that shattered the silence of deep space, not with noise, but with confusion. Discovered in 2018 through data from NASA's Kepler Space Telescope. This unremarkable star, sitting roughly 350 light-years from Earth in the constellation Libra, became the center of one of the most baffling mysteries in modern astronomy. When scientists pored over the final trove of Kepler's light curves, charts measuring brightness over time, they weren't expecting anomalies, but this one was different. It flickered, faded, dimmed, and then returned to normal again and again. Not with rhythm, not like a planet passing in front of its sun. No orbit, no cycle. Just 28 strange, seemingly random dips in brightness over a 97-day span, each with no known cause. The star wasn't flaring, it wasn't pulsing. There were no black holes nearby, no stellar companions to disturb its light. And yet, it dimmed, sometimes slightly, sometimes by as much as 30%. A drastic shift that simply couldn't be brushed off as cosmic noise. Scientists ran every model they could think of. Star spots? Too erratic. Dust clouds, too clean. Planetary transits, impossible. If a natural explanation existed, it was hiding behind the very physics we thought we understood. The environment surrounding HD 139139 is quiet, stable, almost boring. Nothing like the chaotic binary systems or active stellar nurseries where odd behavior might be expected, and that's what made it even stranger. It wasn't the kind of star that should be doing anything at all, yet here it was, blinking like a signal in the dark, cold, precise, and utterly unexplained. At first, HD 139139 didn't seem like anything special. It wasn't unusually bright or massive. It didn't pulse with X-rays or throw off gamma bursts. It just sat there, quiet, steady, a point of light buried deep in Kepler's sprawling data archive. But as researchers, including amateur astronomers, combing through open-source light curves, began charting its behavior, something off-kilter emerged. One dip, then another, then a cluster of them, a pattern that refused to be a pattern. Over 97 days, the star's brightness dropped, not once or twice, but 28 times. No symmetry, no rhythm, no planetary signature, and most disturbingly, no obvious explanation. The initial assumption was straightforward. Perhaps there were planets, lots of them, packed in close, moving quickly in erratic orbits. But orbital mechanics doesn't work that way. Planets don't just move in and out of paths. They follow precise, predictable arcs. And if there really were that many, some of them should have lined up. Some dimmings should have repeated. None did. Back in the dimly lit labs where this data was being analyzed, researchers began building transit models, computer simulations of what kinds of objects could be passing in front of the star to block its light. But the models kept breaking down. No known configuration of natural celestial bodies could account for that sequence. The dips varied in depth, from barely perceptible flickers to plunges that shaved off nearly a third of the star's brightness. That's not dust. That's not gas. That's something big, dense, and erratic. Next came the black hole hypothesis. If there were a black hole orbiting nearby, maybe its immense gravity could distort or obscure the star's light, but a black hole would leave fingerprints, gravitational lensing effects, arcs of bent starlight, radiation signatures. None of them showed up in the data. The area around HD 139139 was eerily clean, like a crime scene wiped down just enough to be suspicious. The team turned to another possible culprit: star spots, cool, dark regions on a star's surface that rotate into view as the star spins. Our own sun has them, and they can cause mild dips in brightness. But even in its most active periods, the sun's star spots dim it by less than 0.5%. HD 139139's dimming events reached up to 30%, and they didn't rotate in. They appeared and vanished abruptly, with no consistent timing and no temperature signature to match a surface phenomenon. By this point, the atmosphere among the analysts had shifted. What started as curiosity had become a quiet discomfort. The data wasn't just unusual, it was untethered from any familiar framework, like a language that looks like it should be readable, but every word is gibberish. The longer you stare at it, the more it feels like it's staring back. One group proposed an outlandish yet mathematically elegant scenario. Maybe we're looking at an artificial structure, something vast, something not bound by planetary or stellar rules. A swarm of objects, or one immense object, with sections rotating or shifting, intermittently blocking the star's light in unpredictable intervals. The idea wasn't fiction. It came from the same toolkit used to hypothesize Dyson spheres, massive energy harvesting constructs theorized by physicist Freeman Dyson in the 1960s. That kind of engineering would require technology light years ahead of ours, but it would explain the irregular dimming. It would explain the silence, because something built for energy collection doesn't need to talk, it just needs to function. The theory hung in the air like static, never officially adopted, never fully dismissed. In scientific circles, you don't throw around the idea of extraterrestrial intelligence lightly. But in 2015, when a similarly anomalous star, KIC 8462852, also known as Tabby's star, showed strange dimming, researchers cautiously floated the alien megastructure hypothesis. It wasn't accepted, but it wasn't laughed out of the room either. Now, HD 139139 had joined that tiny, uncomfortable club, stars that break the rules without leaving evidence. SETI, the search for extraterrestrial intelligence, trained their instruments toward the star. Radio telescopes scanned for signals. Static, nothing, no pings, no pulses, no intelligent patterns, just the cold, unbroken silence of deep space, which only made it worse, because something this strange should leave behind something. It should be noisy, but this was methodical, quiet, surgical, and yet HD 139139 isn't alone in this sense of cosmic dread. In 2017, astronomers spotted Oumuamua, the first known interstellar object to pass through our solar system. It didn't flare like a comet. It didn't spiral like an asteroid. It accelerated without a visible source of propulsion and showed no thermal signature after slingshotting around the sun. Harvard astrophysicist Avi Loeb publicly proposed it might be artificial. The idea sparked outrage, debate, and fascination. Then there's the Popeville Metal Man incident, 1973, rural Missouri. A police chief named Jeff Greenhaw reportedly photographed a metallic humanoid figure that vanished into the night after he encountered it on a deserted country road. His reputation was destroyed, but the encounter, decades later, remains one of the most bizarre and polarizing UFO sightings in American history. These events are scattered, fragmented, they span disciplines and decades, but for those paying attention, they draw lines across the stars, not toward answers, but toward silence, patterns without reason, objects without explanation, a flickering star without a cause, and somewhere in that vast, cold quiet, the unsettling sense that we're not missing the answer. We're not even asking the right questions yet. It all came to a head in June of 2019. After months of back-end analysis and quiet discussions among astronomers, a formal paper was published in the Astronomical Journal titled A Planetary System Transiting a Naked-Eye Star, and authored by a collaboration between professional astrophysicists and citizen scientists. The paper didn't present an answer. It did something far more disturbing. It laid bare the problem in excruciating scientific detail. The dips in HD 139139's light were real. They had been meticulously verified across multiple data streams. They weren't glitches, they weren't artifacts. Something, somewhere, was physically blocking the light of that star 350 light years away, and it was doing so in a way no known natural system could replicate. The numbers didn't lie. Over 97 days, 28 distinct dimming events were recorded, not a single one repeated. Each lasted a few hours. The timing was scattered, like someone throwing darts at a calendar. Depths varied wildly, from minor flickers to deep plunges of nearly 30%. The researchers ran exhaustive orbital models to explain the data. 1, 2, 10 planets. None of them fit. The star's light curve didn't resemble anything from our known exoplanet catalog. It was erratic, non-periodic, yet surgically precise. Every dip had the smooth ingress and egress of a solid object transiting the star, and yet none returned. Nothing in the known laws of astrophysics could explain it. The tension among the scientific community wasn't loud or theatrical. It was quiet, professional, but you could feel the unease in the phrasing of the paper itself. Subtle, careful, but unmistakably charged. One passage read, "The dips are inconsistent with a single object or a simple planetary system. The most plausible scenario is a set of objects with no shared orbital period." No shared orbital period. That one phrase hit like a cold slap in the face. In orbital mechanics, shared periodicity is a cornerstone. If you have transiting planets, they follow a clockwork pattern. Even rogue dust clouds have decay curves. But HD 139139 was showing none of it. Even more chilling was what they didn't find. No infrared excess, meaning there was no dust disk or debris field, no gravitational lensing from a black hole or massive companion, no star spot cycles, no rotational variation, no thermal emissions from passing objects, just clean, quiet dimming in deep space. The very absence of evidence became its own kind of evidence, an eerie, unyielding silence that offered no comfort. The astronomical community, which usually buzzed with hypotheses and press-friendly speculation, stayed oddly restrained. Perhaps it was caution. Perhaps it was fear. Fear of staking reputations on the unexplainable. But beneath that caution was a building pressure, especially as media outlets began to catch wind of what had been quietly dubbed the random transitor star. Unlike past anomalies, like Tabby's star, where dust and comets still offered plausible escape routes, HD 139139 had no fallback explanation. It didn't even offer hope for one. The climax came not with a press conference or a shocking image, but with a single sobering line buried near the end of the published paper. "We have no satisfying explanation for the origin of these events." And with that, the case broke open. Not with revelation, but with total scientific surrender. This was not a case of missing data. It wasn't an equipment malfunction. The Kepler telescope, now silent in space after being retired the year before, had recorded its final anomaly. And what it left behind was not a message, but a warning. Even in death, Kepler whispered something we couldn't understand, and perhaps weren't meant to. Across forums, podcasts, and professional observatories, the reactions range from stunned silence to slow burn panic. If this couldn't be explained, what else was out there? Had we hit a wall, not of technology, but of comprehension? Astronomers like Hugh Osborne, who helped lead the analysis, maintained a calm public front, reiterating that extraordinary claims require extraordinary evidence. But in interviews, you could hear the edge in their voices, the careful pauses, the weight of not knowing. Because this wasn't just a strange light in the sky. It was a cold, mathematical challenge to the foundation of how we think the universe works. A puzzle with no edges, no center, and no image to guide us. Just a repeating whisper from 350 light years away, saying only, "You don't know what this is?" And in the sterile silence of peer-reviewed certainty, that was more terrifying than anything else. To this day, HD 139139 remains unclassified. No updated models, no clarifying data, just a sterile entry in a growing archive of unexplained celestial behavior. The light curves are still there, archived, plotted, and publicly available. Quiet digital traces of something that moved across a star with no pattern, no logic, and no return. Astronomers moved on. Not out of closure, but exhaustion. Papers were filed. Forums quieted. SETI redirected its antennas. There were no follow-ups, no press conferences, just the soft mechanical hum of observatories pivoting elsewhere, pointing at newer anomalies, as though this one had quietly been exiled for being too clean, too cold, too unsolvable. There's something deeply unsettling in the stillness that followed. No signal, no sound. Just a void that swallowed every hypothesis and returned nothing. The space around HD 139139 remains undisturbed. No debris, no background noise, just sharp, dead quiet. Like an open door at the edge of a field, swaying in wind that never touches the grass. The discomfort lingers, not because we saw too much, but because we saw just enough to know, we don't understand any of it. We captured a real event, meticulously documented, confirmed, reviewed, and then left it there. No interpretation, no meaning, just data and silence. And in that silence, there's a different kind of noise, the kind that sinks in late at night, long after the telescopes have stopped turning, long after the headlines have faded, the sense that something was looking back, not with malice or message, but with total indifference, a blank stare from the void, cold, measured, and absolutely real. No follow-up mission has returned to HD 139139. No telescope has captured another dimming. The star remains frozen in official records, marked only by 28 silent events that defy classification. Its light doesn't flicker anymore, or maybe no one is watching closely enough to see. The data sits untouched, its numbers intact, its meaning absent. In the years since, no known system, natural or artificial, has reproduced the same pattern. It appeared once, without context, without repetition, and then vanished. Not into theory, not into myth, just into a silence so complete, it feels like something was deliberately erased.